if G is a group of order 8, then which of the following statements are necessarily true? One thing that you can see is G is a group of order 8. First thing. So G is a finite group of order 8. So if I actually go through the options, I can notice that in every option they are asking about the elements of order 4. First option says that if G has no element of order 4, G is abelian. If G has exactly 2 elements of order 4, G is abelian. If G has exactly 6 elements of order 4, G is abelian. That fourth option is there is no element of order 4 in G. Or there is an element of order 4 in G always. So they are always talking about the elements of order 4. Also, if order of G is 8, then what are the possibilities for G? We know that if order of G is 8, then up to isomorphism, there are 5 possibilities for G. And what are those? So let's write it down one by one and check the elements of order 4. Z2 cross Z2 cross Z2, Z4 cross Z2, then Z8. These are 3 abelian classes. Next we have is D4 and next is Q4. If I mention the number of elements of order 4, then this has no element of order 4. If I see this, then we know that A comma B has order 4 if GCD of order A and order B is, if ACM of order A and order B is 4. So the possibilities are either I can take, it has 2 elements, it has only one element of, it has 2 elements, 5 or 4 elements of order 4. So it has only 2 elements of order 4. And if I take its GCD with 2, it has to be 4, or GCD with 1 is 4. The possibilities, I can take 2 elements from here and 2 elements from here. So this has 4 elements. I can take identity and then 0, 1, 2, 3 mein 1 and 3. 1 identity, 3 identity, 1, 1 and 1, 3, 1. So there are 4 elements of order 4. Z8 is a cyclic group. It has 5 or 4 elements of order 4. D4 is dihedral group of order 4. It has again 2 elements of order 4. And Q4 is quaternion group of order 8. It has 6 elements of order 4. Now we will go through the options. If there are no elements of order 4, which case they are talking about? Z2 plus Z2 plus Z2. If there are no elements of order 4, then G is abelian. Correct, because they are talking about Z2 cross Z2 cross Z2. Because it's in this case, there is only one possibility, Z2 cross Z2 cross Z2. If there are exactly 2 elements of order 4 in G, then G is abelian. If number of elements is exact 2, then G is abelian. Is this statement always true? No, because in case of D4, there are exact 2 elements of order 4, but G is not abelian. So in case of D4, G को let G is equals to D4. So this statement is false, non-abelian आएगा मेरे पास. Moving to the next option, there are exactly 6 elements of order 4 in G. Then which group they are talking about? Q6. Q6 has 6 elements of order 4. Then G is abelian. Is Q6 abelian? No, Q6 is not abelian because Q6 has elements of the form plus minus 1, plus minus I, plus minus j, and plus minus k. And I into j is not abelian. I into j is k, j into I is minus k. There is an element of order 4 in G. It says that the number of elements of order 4 कम से कम 1 तो हो गई होगा. क्या ये हमेशा possible है? नहीं. Because Z2 plus Z2 plus Z2 has no element of order 4. It has 1 element of order 1 and 7 elements of order 2. So this statement is also, even though it is a part C question, it has only one option